Grocery store purchases melons from two distributions, J and K. Distributor J provides melons from organic farms. The distribution of the diameters of melons from distribution J is approximately normal with a mean of 133 millimeters and a standard deviation of 5 millimeters. For a melon selected at random from distributor J, what is the probability that the melon will have a diameter greater than 137 millimeters? I want to show you how to do this on the Inspire, and then I want to show you how to do this using the Staplet app. So we know that the melons from distributor J are normally distributed with a mean of 133 and a standard deviation of 5. And I want to know what's the probability that the melon will have a diameter greater than 137. What's the menu we're going to use there? 552. So let's do it both ways. Let's do menu 552. What's the lower bound for this one? 137, upper bound, a bunch of 9s. The mean is 130. Is it 133? And a standard deviation of 5. So what's that probability? 0.2119. Now, how would we do this using Staplet? So Staplet would go to normal distributions. So go ahead and do that. Go to, open up another tab. Go over here. And we said normal distribution, 133, was it 5 or 4? 5? So drops that curve where the mean is 133 and a standard deviation is 5. And now, I mean, this is actually like super intuitive, but you're not going to have this option on the AP exam. So I want to find the area to the right of a value and saying the value is going to be, what was it, 137? Is that what it was? 137? So we're saying what is the probability that something is to the right of 137? And it shades it, so that's nice. And then it tells you that area is 21.19% of the total, or 0.2119. Just so that you know how to navigate this, let's do between two values. By the way, if I do between 128 and 138, what do you expect to get? 68%, right? So 68.27%, because it's within one standard deviation of the mean. And let's talk about how to find, if I want to know the bottom 10% of melons, bottom 10% of melons weigh less than how much? On the TI Inspire, how would I do it? What's the menu on the TI Inspire? Let's do it. If I want the bottom 10% of melons. Menu 553. And if I want the bottom 10% of melons, what's my area? 0.1, because I want the bottom 10%, with a mean of 133 and 5, right? So the bottom 10% would weigh less than 126.6. If I'm doing 4 sig figs. Over here, calculate value corresponding to an area. So same thing, 133 and 5, and I want boundary to the left of, I hope this works. Yeah. So to the left of left tail with an area of 0.1 is 126.6. Now, What about to the right one? If I do right tail, the thing about Staplet is you can just put in 0.1 and it's going to do it. But on the TI Nspire, you can't. So if I want the top 10% of weights for the melons, 139.4, how would I get the top 10% on here? So menu 553, what's the area for the top 10%? 0.9, 133 and 5. So go ahead and do that, just so that you go through the mechanics. I think going through the mechanics is important. Raise your hand once you have that on your screen. Successfully have that on your screen. Cool. Where is it? Okay. So A. For a melon selected at random, what's the probability that the melon will have a diameter greater than 137? What do we say, 0.2116? Is that what we said? Can't remember. Roughly that. Distributor K, wait, yes, no? Okay. 2119. Thank you. Distributor K provides melons from non-organic farms. The probability is 0.8413 that the melon selected at random from distributor K will have a diameter greater than 137. For all melons at a grocery store, 70% of the melons are provided by distributor J and 30% are provided by distributor K. All right, so the store has a combination of melons provided by distributor J and K at a 70 to 30 ratio. For a melon selected at random from the store, what's the probability that the melon will have a diameter greater than 137? All right. So the melons can either be from J or K. What percent are from J? 70%. 70%? And the others are from K? So 30% are from K? Now, they are either greater than 137, I'll just say greater than 137, right? Or less than 137, greater than 137, less than 137. And for J, the probability that they're greater than 137 is what? For J, 2119. And what about for K? What's the probability that they're greater than 137 in diameter?
0.8413.
Raise your hand if you see where we get that number. Where we get that number. So that number, they tell us that the diameter is greater than 137.
What's the number?
The 2119?
I see now. I see now.
Cool. For a melon selected at random from the grocery store, what's the probability that the melon will have a diameter greater than 137? That means they're either from J and have a diameter greater than 137, or from K and have a diameter greater than 137. So give that a shot and see how you do on that one. See what you get for B. Check with your neighbor once you have it. Who got what I got? Who got what I got? So multiply across and then add them, right? So we would say multiply this by this, and then multiply this by this, and then add them together. Multiply across, add straight up and down. So what is it, 0.40072? Is that right? 407? All right. Given that a melon selected at random from the grocery store has a diameter greater than 137, what should you be thinking right off the bat there when you read that? Yeah, whatever follows the given, what? Goes on the bottom, right? So given that a melon selected at random from the grocery store has a diameter greater than 137, so we just calculated that. What is the probability that the melon will be from distributor J? Give that a shot. See what you do. See what you can do on that one. All right, so how do I get the numerator? Yeah, so we know what's probably the melon will be from distributor J. So out of these two, from distributor J is 0.7 times 0.2119. And what does that end up being? 14833.
Whoa, no. 0.37. 0.37015.
That's after you divide.
Oh, wait, I was doing 0.7 times.
So
0.37015.
So 2.
Yeah.
Well, yeah, I got that as the answer. I was just talking about the numerator.
Got it. Okay, cool. So how does that look? 3702? 3702? Yeah. So this is a very much the kind of problem that is like totally fair game for next week's quiz, where like you've got menu 552, and then you've got to do like a combination probability tree slash like 552 stuff, and then you've got to do one of these where it's like given something. Yeah,
Is the quiz on Monday or Tuesday?
probably Tuesday, like not on Monday. Monday quizzes are. Oh, like on the quiz?
Yeah, like a hint.
I don't think that's a hint.
Helpful. I mean, if you plug in the numbers wrong, then it's on you.
That's
Wait,
true.
Do I have to tell you on the quiz, like, do we have to write down which one to use, like menu 553? It would be nice to know which one.
So not yet, but like at some point,
What does that mean? Is it this like Mr. Brooks?
Yeah,
Like-
Mr. Brooks makes us do it. He's not Mr. Brooks.
so like as we get closer to studying for the AP exam, because my plan for the next quiz is to be like pretty much on Socrative. Bless you.
Like on
So not a lot of writing, right? So yeah, for that, there's no need to do that. But in the spring, once we start working through FRQ packets, then I will want to have more of that, like more of you writing down menus and such. Okay. Let's look at z-scores. So, so 100, 115, 130, 85, 70. Normal distribution with a mean of 100 and a standard deviation of 15. So we talked about the that as being the what? The distribution of
IQ scores.
Yeah, IQ scores. How many of you guys have heard of a z-score?
I haven't heard of it since your class.
But maybe my class?
Sophomore year.
So since sophomore year.
So a z-score tells you how many standard deviations a score is from the mean. And here's the formula for z-scores. Oh, this is so easy.
I know.
Huh?
It's not that.
I know.
You should make it a given though.
I should what?
Like put it on the paper.
Sure, yeah, I can do that.
Really?
Yeah, yeah. I can give you that one. So z is x minus mu over sigma. So,
Do we get that on the AP test? Or?
yes.
No.
Yeah,
Given it. Ah, I see.
right. So for example, find the z-scores for the following. For the following IQ scores. For an IQ score of 115, for an IQ score of 70, and for an IQ score of 107.5. So use the z-score formula to find the IQ scores when IQ is 115, when IQ is 70, and when IQ is 107.5. Of course. That's a fair request.
She always.
No. Totally fair.
Yeah, you should just say it in a weird way on that side.
No,
I didn't call it like a big head. I just said it.
Move your way
On the slide. Can you shift your ears? Happy? No, you don't. I did not take it to be rude. Don't
No, but
worry.
everyone else did. So.
Yeah.
Can you scroll up so we can like see the mean and stuff? I didn't write that down. Oh, is this like the absolute value or can it be negative?
It can be negative.
Thank you.
Oh, I did it.
That's what I was waiting for.
Wait, no, you put it.
I used the melon example.
I was waiting for that.
Jesus. I'm about to call your mom. No cap.
Move your head. All right, Boone, what'd you get for the first one?
1.
So Boone got 1 for the first one? Yes, no? So how'd you do it?
115 minus 100 over 15.
So,
Over 15.
oh yeah, sorry.
I'll forgive you.
So 15 over 15 is 1. So a score of 115 means that someone is 1 standard deviation to the right of the mean. Right? 1 standard deviation to the right of the mean. What about 70? What's the z-score for that? -2. Right? Because 70 minus 100 over 15 is -30 over 15, which is -2. So if you have an IQ score of 70, you are 2 standard deviations to the left of the mean. All right, what about 107.5? Sounds like a radio station, not an IQ. So 0.05? 0.5. So that's a standard deviation. So that is, someone is 1/2 of a standard deviation to the right of the mean. Right? So when do z-scores become important? So by the way, the standard normal curve. So standard normal curve looks like this. Standard normal curve is centered at 0 and has a standard deviation of what? Take a guess. 1. That's a good guess. That's correct. So standard normal curve has a mean of 0 and a standard deviation of 1. We will use this quite a bit later. For now, just to practice on the calculator, find the area on the standard normal curve between -2 and 2. By the way, what do you expect to get there?
98,
95.
95.
Let's find out.
It's 95.
All right, so put it in. Did you get it?
Yeah.
Cool. How many guys got it? 95, 0.95? Yes, no? The question is, find the area between -2 and 2 on a standard normal curve, where the mean is 0 and standard deviation is 1. So between -2 and 2 with a mean of 0 and standard deviation of 1. By the way, the default on your calculator is a standard normal where the mean is 0 and standard deviation is 1. So 95.5%? 95%. All right. Where? One second.
So the British control Iraq, French control Palestine.
French controlled Lebanon.
And international control that are not.
See, the way I remember it is the British got more like French, so it got more territory.
All right, let's look at this question. So this is question 1 from the 2011 AP exam. A professional sports team evaluates potential players for a certain position based on 2 main characteristics, speed and strength. So they look at players from the perspective of speed and strength. Speed is measured by the time required to run a distance of 40 yards, so the 40-yard dash, with smaller times indicating more desirable, faster speeds. Good to know. I see you at a smaller time. That means you have a more desirable speed. Thanks, coach. From previous speed data for all players in this position, the times to run 40 yards have a mean of 4.6 seconds and the standard deviation of 0.15 seconds, with a minimum time of 4.4 seconds. So the mean is 4.6, standard deviation is 0.15, and the minimum is 4.4. Based on the relationship between mean standard deviation and minimum time, is it reasonable to believe that the distribution of 40-yard running times is approximately normal? Explain. If you're given this data, is it reasonable to think that this data is normally distributed?
Nope.
We have a nope. Emily, what do you think?
I mean, I don't think so.
She does not think so. Who wants to
Challenge.
elaborate?
I can
Go ahead.
I mean, I don't, is the standard deviation, is that,
Like, what about it?
like, I don't know. Close to 0.
So, since the minimum is 4.4, you can only go 1 full standard deviation to the left.
How do you guys understand what he's saying? So, let's look at it this way. So, all right, so the mean is what here? 4.6. So if I go 1 standard deviation to the left of that, what is the mean going to be? No, what's that going to be if I go 1 standard deviation to the left of that? So 4.45. And then if I go 1 more standard deviation to the left of that,
Your chair's in the way.
4:30.
Just sit on the floor at this point. Your
so,
head, your
so
fingers.
4.6, right? If I go 1 standard deviation to the left, it's 4.45. If I go 1 more standard deviation to the left, I'm at 4.3. But what's the minimum?
4.4.
Yeah, 4.4, right? So I can't even go 2 standard deviations to the left, which means it's not going to be normally distributed. Because with a normal distribution, you can go quite a few with a normal distribution, you can go like technically infinitely to the left. But if I can't even go 2 standard deviations to the left, it cannot be normally distributed. Strength is measured by the amount of weight lifted, with more weight indicating more desirable, greater strength.
Smaller.
From previous strength data for all players in this position, the amount of weight lifted has a mean of 310 pounds and a standard deviation of 25 pounds, as shown in the table below. Calculate and interpret the z-score for a player in this position who can lift a weight of 370 pounds. Find the z-score, and let's talk about what that interpretation is going to be. So a player can lift 370 pounds. Find the z-score for that. And then check with your neighbor once you have it. So check with your neighbor what you have for that.
Is this sheet on campus?
Ella, do you have the number for that? 2.4. How many guys got 2.4 for that? 2.4. So you did 370 minus 310 divided by 25, and you got 2.4. So how would we interpret that? So the interpretation of that is this player can lift an amount that's 2.4 standard deviations to the right of the mean. So this represents an amount 2.4 standard deviations to the right of the mean. So now we're kind of getting at the crux of what this problem is asking, or getting at. The characteristics of speed and strength are considered to be of equal importance. And I'll post this problem on Canvas. Based on the information about the mean and standard deviations of the speed and strength data for all players and the measurements listed in table for players A and B, which players should the team select if the team can only select one of the two players? Justify your answer. All right, so you have player A and you have player B. Who is the faster player? Player A? Yeah, player A is the faster player. Who's the stronger player? Player B. So player A is faster, but player B is stronger. So the question is, assuming both matter equally, speed and strength, which player should the team choose? Let me give you like a couple minutes to see what you can do with that.
For a second, I saw 370 and I was thinking weight, and I was like, that 374. Running a 4-4. I was trying to imagine like
I think there's a bigger difference.
an offensive tackle.
By the way, what do you think you'll be using to do this? What have we been talking about?
Z-scores.
Z-scores, yeah. So calculate the z-scores for all four of those statistics.
What's the median time?
There you go.
6.
Can you see these okay?
Acting like a quick.
I think this one's 2.4. Is that right? Who's got the z-score for the 375 pounds? 2.6? What about the z-score for player A's time? Negative 1.2, you said? And what about this one? Negative 0.2? All right, so take a moment and decide which player would be better for the team to pick overall? Player A or player B? And then tell your neighbor what you think. Tell your neighbor what you think.
What do you think? That's what I'm thinking. Is it higher Z-score? Well, like a lower Z-score for the time.
All right, so here's the question. For the weight, do we want greater z-scores or smaller z-scores?
Greater.
Greater, right? More weight is better. Lifted. What about for this one? Do we want lower z-scores or higher z-scores? Lower, right? Because lower means you are faster, and faster is better, according to the coaches here. So, all right. Do we want player A or B? A. Why?
Because the
Even though the easy scores is greater than the difference in the z-scores for weight.
The weight wasn't that much.
Yeah, so here, they're both significantly stronger than the average, right? But player B is only 0.2 standard deviations stronger than player A. And for speed though, player A is much faster than average. Player B is kind of close to the average. And the difference here is a difference of a whole standard deviation. So, they're both much stronger than average, but player B is only a little bit stronger than player A. Player A is much faster than average, and player B is faster, but not too much faster than average. So player A. Does that make sense? So this is where z-scores help, is they allow us to kind of compare apples to oranges. So they can compare, you can get a sense of how someone's speed and strength compare to the average. Okay, so go to Socrative. Let me see. Launch. So go to AP Stat 2021 and give it a whirl. These will be a combination of a number of things, by the way, so.